We are live. 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 We are live.
Over the edge, feel like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to kick the habit that my mind is breathing in. Break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless.
What's up with y'all boys, bro? What's up with y'all boys, bro? What's up with you guys, man? Welcome to today's stream, y'all. Welcome to today's stream. Just put this here. Pin this message. Okay. Welcome to today's stream, y'all. So today, what the game plan? We're gonna continue with our exercises here. Now, after this, there are some recursion exercises, and I just started reminding myself recursion. So we're gonna see how that goes. So the game plan is, and also after these recursion ones, I have some bit manipulation ones. So we'll see. Maybe we're gonna first try to do the recursion ones. Then if we can, then we're gonna go to the bit manipulation depending on how we do there. Okay. Yeah. So that's basically the game plan. Let's start with the first one. We've got majority element. So we're gonna bit slash std++.h using namespace std int main. Right there. Okay, so majority element. So we want to return the element which appears the most amount of times in this array. Okay. All right. So first, let's do the hash map. Uh, let's do the hash map approach first. Element, because that's gonna require less thinking on my part. And I'm gonna have an array. I'm gonna say map of int and int m. I'm gonna say for int num in array. We're gonna say m of num plus plus. Then we are going to don't have ans is equal to say r of 0 for now. And then we're going to loop through the map. So for every pair in the map, if the if the count um, if the count of it is greater than m of ans, then we're gonna say ans is equal to p dot first. Okay, okay. So what are we doing here? So first we're setting. Okay, actually, let's just return the answer, then see if this works, and then I'm gonna explain it. Okay, so vector of, we're gonna say like this, then we're gonna see out majority elements of R like this. We're gonna run this. Okay, let's see. Okay, we get 3. Okay, now let's make something. Let's say that 3's are 2 and 2's are 3. Now we should get 2. We should get 2. Okay, seems to work. So what are we doing? So we're going to count the frequency of each array with the map. So first, for each number in the array, we are going, if it's not in the map already, we're going to put it in the map, and this is going to set its value to 1. If it is in the map, if it already is in the map, this is going to be, it's going to increment the count of how many times it appears inside the map. Here we set the answer to the first element by default, so when we return, we don't get any errors. And then we check all of the pairs in the array. So if the current number has more appearances than the number inside of ans, then we're going to set answer to p dot first, which p dot first is that number. P dot first is the number, and p dot second is the amount of times that this number appears in the array. And then we're just going to return the answer. Okay, so let's try to solve this in a naive approach now. And this one is going to be okay. So what does a naive approach look like? So I'm thinking we're going to how do we do this? Simple tracking. Got into frequency thinking. So what are we gonna do? How do we get this in a naive way? So we're going to have the number. Then okay, so I'm thinking we're gonna push all of the numbers in an array, and then okay, okay, yeah, I cannot think of the naive approach right now, so we're just gonna continue with the recursion ones. We're gonna continue with the recursion ones. So we got first one, print numbers 1 to n. So this one shouldn't be that bad. This one shouldn't be that bad. So we got would print, have int n. So if n, so print numbers 1 to n. Print numbers 1 to n should be 1, 2, 3, 4, 5. So we get 5 and we get 1, 2, 3, 4, 5. In base case, because will cost a quarter. And minus 1. Okay, so if n is equal to 0, we are going to return else we are going to call print of n minus 1, and then we're gonna see out n into here. Okay, and this should work. Let's try it. Print, and I'm gonna go through like the whole explanation of this as well, just in a second. So let's say we have print 5. This should give me 1, 2, 3, 4, 5. Okay, let's see, 1, 2, 3, 4, 5. Okay, so we get 1, 2, 3, 4, 5. Now let's dive deeper into the recursion, and I'm gonna try to explain this as best as I can. Now, I haven't done recursion in a while, and I just recently started to refresh my memory, so my bad if the explanation is not 100% correct or not that good, but we're gonna explain this anyways. So let's start to debug. Okay, so we're gonna start to debug. So first off, we start. Now, first, the main function gets pushed onto the call stack. Then we're gonna step into, and now the print function is gonna get pushed into the stack as well. So we go step into, as we can see, the print function has been pushed to the stack. Now the value of n is currently 5. So is 5 equal to 0? Well, it's not. So we're not gonna return. Instead, we're going to come here. Now we're going to call print with 5 minus 1, which is 4. So print 4 is going to get pushed onto the stack right here, as we can see right there. So now the num n is 4. We can see n right here as well. We can see n right here as well. So currently n is 4. Is 4 equal to 0? Well, it's not. So we're going to call print again with 4 minus 1, which is 3. So this is going to get pushed onto the stack. We're going to see another print right here. There it is. So now n is 3. Is n equal to 0? No. So we're going to call print again and push it onto the call stack. Boom. So now n is 2. Is it 0? No. Print gets called again, pushed right here. So we've called it 1, 2, 3, 4, 5 times. So right now n is 1. Is n equal to 0? No. We're going to call print one last time. Now, is n equal to 0? Yes. So we're going to return. And out of where is it going to return from? It's going to return out of right here. It's going to return out of right here. And then it's going to be like, okay, hey, print, I have called you first with print 5, I have called you with print 4, I have called you with print 3, I have called you with print 2, I have called you with print 1, and I have called you with print 0. And print is going to be like, okay, I'm done now. So, and basically print of 1 is going to be like, okay, print of, wait, print of 1 or print of 0 is going to be like, okay, I'm done now. So, it's going to get returned, and basically we're at this point we're going to print 1 because it returns and we don't get past 0. Then here we go, it's gonna get printed. So 1 is printed right here. So, and now, okay, let's see, 1, 2, 3, 4, 5. Okay, I'm gonna watch this. So now we are at the case where n is 2. So okay, so I'm gonna print 2. Okay, 2 gets printed. So now we have 4 left. 4 of these left. So now we're gonna step into, now n, we're back to the call where n was 3. So it comes out of here and it's gonna print, it's gonna do everything else, which is until the bottom of the function. So then it's going to, now we're going to print 3. 3 gets printed. Okay, so print 3. Now I'm done. Print 3 is done. So now it's time for print 2 to finish. Print 4. For print 4 to finish. Okay, so it's gonna so print 4 is going to print 4. Okay, no problem. We print 4. And lastly, we're at print 5. So right here at first it was called with print 5, and now we have only one print function left inside the call stack. This is the first one we called, we print 5. So now n is 5. It's gonna be like, okay, let's print 5. Is there anything else to do? No. So print is gonna return, and print gets popped from the stack, and now just the main function is left. So the main function is like, okay, I called print with 5. Print is done. Is there any other functions I need to do or anything else I need to do? No. So it's gonna get popped off the call stack, and there we go. That's it. That's it. There we go. Okay, let's stop the debugging. I tried to explain it as well as I could. So hope it was useful for at least a little bit. Okay, so let's move on to the next one. So print n to 1. Okay, so this is print. This is print. Let's call the next one void print to. Now I think this one is going to be a little less confusing because we're going to say if n is equal to 1, we're going to see out n, and we're going to return okay, there we go, see out, else we are going to see out n, and then we're going to call print 2 of n minus 1. Okay, so what are we doing? What is the difference? So in the other one where we were printing from 1 to n, first we pushed everything onto the call stack. So we pushed 5 on the call stack, then we pushed 4 on the call stack, then we pushed 3 on the call stack, then we pushed 2 on the call stack, then we pushed 1 on the call stack. And once everything got pushed, that is when we returned. And when we returned, is going to return out of the last thing we pushed. The last thing we pushed was print with 1. That is why first we got 1. Then the last thing before that was print with 2. That is why we got 2. The last thing before that was print with 3. That's why we got 3. The last before that was print 4. That's why we got 4. The last one before that was print 5. That's why we got 5. And here it's going to be different. So here first, it's going to check if n is 1. If no, we're going to print n. So let's say we call n with 5. So is n 1? No. So we are going to print n, which is 5. Then we are going to call print with 4. Is 4 equal to 1? No. We are going to print 4. Then we call it with 3. Is 3 equal to 1? No. Then we're going to print 3. So then we call it with 2. Is 2 equal to 1? No. So we're going to print 2. Then we call with 1. So is 1 equal to 1? Yes. Then and afterwards we're going to print 1, and then print 1 gets popped off the stack, print 2 gets popped off this, print 1 finishes, print with 1 finishes, print with 2 finishes, with 3, 4, 5, and that's basically it. So let's get 5, 4, 3, 2, 1. Okay, let's put this in debug as well, so it is even more, so you guys can see this. We're going to go to the debugger right now. Okay, so first, what's gonna happen? First, main is going to get pushed onto the stack. There we go, we've got main. Then print 2 is going to be pushed onto the stack. So we step into print 2 is right there. Okay, first in the function. So n right now is 5. Is 5 equal to 1? No, it's not. So we're not going to go inside of this condition. Instead, we're going to come here. We're going to print 5 right here, gets printed. Then we're going to call print 2 with n minus 1. Now n is currently 5. 5 minus 1 is 4. So we are going to call print 2 with 4. It's going to get pushed up right here. There we go. It comes here. So is 4 equal to 1? No, it's not. We're going to see out 4. There it is. We're going to call print 2 with 3 right here. Is 3 equal to 1? No. So we're going to see out 3. Call print 2 with print 2 with 2 now because 3 minus 1 is 2. We're going to get pushed onto here. Is 2 equal to 1? No, it's not. So we're going to see out 2, print 2. There we go, right here. So print, then we're going to call print with 2 minus 1, which is 1. Okay, so gets pushed on the stack right here. Okay, so now is 1 equal to 1? Yes. So we're going to come in here. We're going to print 1. There we go, 1 right here. And then we're going to return. Now, where is this going to return from? Where is this going to return from? It's going to return from right here because that's where the function was called. The function returns from where it was called. So it's gonna be like, okay, we're gonna return. I already did, we're gonna return. So we did everything, so we're gonna pop out of here. And this should get popped off the stack. Let's watch this right here. Okay, so return. So print 1 returns. So this is gonna get popped. 3, 2, 1. And that's basically it. There we go. So main is done. Main doesn't have anything else to do. So main is going to get popped off the stack as well. And there we go. That's basically how that works. That is basically how that works. Okay. All right. So next one. Okay, we printed n to 1. Let's see what the next one. Sum of first n numbers. Okay. Sum of first n numbers. Okay, n plus sum of n minus 1. This is actually the first. Okay. So guys, as I told you yesterday, as I said on yesterday's stream, I have not solved recursion in like a year, like 1 or 2 years. So right now, that's why I'm doing problems which are of this easy level. Okay, so now we're going to do sum of first n numbers. So we're going to say int sum of n. We're going to have n. So if n is equal to 0, we're going to say return. We're going to say return. What are we going to return? N. Actually, we're going to, I think this is going to have to be 1. And then we're going to return, we're going to return n plus sum of n minus 1. Now, don't quote me on this. Let's see if this works. So we're going to see out. I'm going to see out sum of n of 5. And this should give us 15. 15. Okay, we get 15. Okay, we get 15. So first, sum of n. So first off, okay, let's do this. So first off, sum of n is called with 5. So 5 is right here. Is 5 equal to 1? No. So then we're gonna go 5 plus. Okay, guys, I think I'm gonna open the paint. I'm gonna try to make a recursive tree in paint. Okay. So okay, so at first n is equal to 5. Okay, at first n is equal to 5. How do you select? Okay, like that. So at first n is equal to 5. So is n equal to 1? Is 5 equal to 1? 5 is not equal to 1. So then we're gonna do this. We're going to do five. Basically, we're going to do 5 plus plus 5 plus 4. Okay, we're going to do 5 plus 4. Uh, okay, we're going to do 5. We're going to call 5 plus 4. We are going to call 5 plus 4. Actually, plus, not plus 4 yet, because actually, not plus 4 is going to be, we're going to call 5 plus sum of n with 4. Okay, okay. So, oops, get the select. Okay, so this is what happens. So when 5 is equal to, and when n is equal to 5, first we're going to check, is n equal to 1? No. So we're going to return this. We're going to return n plus, and then here, since this is a function call, it's going to get called, this is going to get called with 4. So, so then, so then n, so then guys, n is going to become 4. Okay? Now, we are going to check, is 4 equal to 1? No. So this is what's going to happen. Basically, we are going to have 4 plus sum of n, which is 3. Okay? And even, let's see if we can make some sort of stack looking thing right here. Some sort of stack looking thing. Uh, so, so first off, first things first. First things first. First, what do we have? First, we have the first function, which is the first function that gets pushed onto the stack. No, it's not sum of n. The first function which gets pushed onto the stack is main. Is main. Okay? After that, what gets pushed onto the stack next is sum of n of 5. Okay? Sum of n of 5. Alright? Then, now n is equal to 4. So then what gets pushed is sum of n of 4. Okay? Then we push sum of n of 4. Alright, so now we got sum of n plus sum of n of 3. So then we push sum of n of 3. Okay? Sum of n of 3. So now n is equal to 3. Now n is equal to 3. So is 3 equal to 1? No, we're not going to return. Instead, we're going to call sum of n with 3 minus 1, which is 2. So right now, n is equal to 3, n is equal to 3, oops, n is equal to 3, and then we're going to call 3 plus sum of n of 2. Okay? 3 plus sum of n of 2. So, what will happen to sum of n? So sum of n is going to get pushed, sum of n is going to get pushed onto the stack like this, okay? And then we call, and then n is going to be equal to 2, all right? N is going to be equal to 2. So is 2 equal to 1? No, it's not. So we're gonna call this one last time. So we're gonna call this with, this is what becomes now. It is going to be 2 plus sum of n of 1. This is the last call. The last call which is gonna be pushed onto the stack for now. Right now, actually. So what happens? Then sum of n is 1. Okay. Oops, what happened? Okay. Okay, let's rewrite this. Now right here, sum of n is 1. All right, and that's basically all of our function calls. Now, finally, n is going to be equal to 1. Finally, n is going to be equal to 1, right? N is going to be equal to 1. So now n is equal to 1. So are we going to return? Yes, we're going to return n. We're going to return n. And what is n currently? What is n currently? N currently is 1. So right now, this is going to return, it was called here. So it's going to return from where it was called. It's going to return right here to this. Okay, this is a little, I'm going to make this sticker, brushes. So right here is going to be called return here, and this is going to return, this is going to be right here 1. So that's going to return 2 plus 1. This one, so the guys, this one, so this one returned. This right here, right now is 1. And this right here, right now is 2. All right? Because basically what happened? Why does this happen? It happens because we called sum of n with 1. Then sum of n with 1 hit our base case. And it returned 1. When the function returns, it gets popped off the stack. How to make this bigger? Okay, like this. Okay, so this gets popped off the stack and it returns 1. So now we are back into sum of n where n is 2. So n is 2 right now, and this is returned 1. That's why that happens. That's why we get 2 plus 1. Okay? And then 2 plus 1 is equal to what? It's equal to 3. Okay? So this is equal to 3. This is equal to 3. And now what's going to happen? What is this going to return? So right now, sum of n, where n is 2, is going to return. And 1 is going to return. You're right, it's going to return 3. Where? Right here. Right over this one. Okay, so we go up again. So this right here, oops, not this. So this is going to return from here. And the return value of this is 3. So it gets 3. So it gets 3. And this right here returns 3. Okay, guys? So, so sum of n, where n is 2, has returned, okay? So now it gets popped off the stack. Now, what happens now? What happens now? What happens now is we get 3. Right now, n is equal to 3. So n is equal to 3, and sum of n of 2 returns 3. So what is 3 plus 3? 3 plus 3 is equal to 6. It's equal to 6. Okay? It's equal to 6 right here. All right? And then this returns. So it's equal to, it returns this. So we go. So this is too big. So now this right here, so sum of uh yeah, right now we are at sum of n, sum of 3, sum of n 3. So we go up right here. Okay, this is, we go right there, and this returns sum of n of 3 has returned 6. It has returned 6 like this. So now it has sum of n of 3 has returned, so it gets popped off the stack. Okay, now we are on sum of n of 4. So since sum of n of 3, so sum of n of 4 returns sum of 4 plus sum of n of 3. Now we know sum of n of 3. Sum of n of 3 is 6. It is 6. How much is 4 plus 6? 4 plus 6 is 10. 10. All right. 4 plus 6 is 10. So right here, sum of 4 returns 10. Okay. So it has returned. And it returns from where? It returns from here. It returns from here. Okay. Returns from there. So we get 5 plus 10. Basically, we get 5 plus 10. Okay. So where is, there we go. And this returns to here. It returns to there. And it returns 10. It returns 10. All right. Returns 10. There we go. Okay. So now sum of sum of n of 4 returned. So it has done. It is done. It gets popped off of the stack. Now, all is left is sum of, all of the sum of n function is left is sum of n of 5. Now, sum of n of 5 is, it returns n, which is 5, plus n minus 1, which is 4, which is sum of n of 4. And sum of n of 4 has returned 10. So our final result is 5 plus 10, which is 15. It's 5 plus 10, which is 15. That is our final result from all of this function calling. This is 15. Okay? And that is why we got the answer 15. That is why we got the answer 15. Okay? All right. Hope that's clear. That is why we got 15. And now this returns 5 plus 10, which is 15. So now all sum of n of 5 has returned. Now what is left? It gets popped off the stack because it has returned. Now the only function that is remaining on the stack is the main function. But now in this function we call sum of n of 5, and sum of n has returned already. So basically this is counted. There is nothing else to do. So main also returns and it gets popped off the stack. And that's basically the whole explanation of that. That is basically the whole explanation of that. That is the explanation of that. Okay. If you guys have any questions, make sure to ask. Make sure to ask if you guys have any questions. All right. Okay, next one, factorial. Okay, so this is basically almost the same. This is almost the same, but instead of adding, we're going to multiply. So if n equals to 1, we're going to return n. Otherwise, we're going to return n times fact of n minus 1. And this should give us 120 if I'm not wrong. There we go. We get 120. 120. Okay, guys? That's what happens there. So basically, right here, the process is the same. All of the same happens. All of the same. But instead of plus, we have multiplies by. Okay? That is basically what this does. Do you guys want me to go through? Okay, you know what? No, no. I'm going to debug this. Going to debug so we can see this easier. Okay, so first we gotta start. Okay, so we have started. The main function gets pushed onto the stack. The main function gets pushed onto the stack. Okay, we step into fact gets called. Fact is pushed onto the stack with value 5 currently. So because n is 5. Okay, n is 5. So now, is 5 equal to 1? Well, no. So we're not going to go into this. Instead, we're going to come here. We're going to come here. We're going to return 5 times, and here we are calling the function again. So this is going to get put 5 times n minus 5, n minus 1, which is 4. So now this is going to get pushed onto the stack. We're going to see right here. Okay, there we go. Boom, another one. So now n is 4. Is n is 4 equal to 1? No. So we're going to call this again, this time with 3. There we go. Okay, here we go, another one. So now is n is equal to 3. Is n equal to 1? No. So we're not going to return from here. We're going to go here. This time we're going to call it here with 2. Boom. There we go, 2. So now, is 2 equal to 1? No. Okay, so then we're going to call it with 1. Okay, so is 1 equal to 1? Yes. Yes, it is. We're going to return and we're going to return 1. We're going to return 1. Then we get 1 times, then this returns 1. The previous one is 2. So first is 2 times 1. Okay. Then the previous one is 3. So that is 3 times 2, which is 6. Then it's 4 times 6, which is 24. And then finally it's 5 times 24. Finally it's 5 times 24, which is 120. And we have, and this fact is done. Now, is there anything more to do in main? No. So main is going to be like, okay, I'm done. So I'm just going to pop off, I'm going to remove myself from the stack. There we go. There we go. That's what happens. That's what happens. All right. Okay. Yeah, if you guys have any questions, make sure to ask. Make sure to ask if you guys have any questions. Okay? Okay. Next one. Let's see the next one. Hello and times. All right. So, let's try this one. Let's try this one. Oops, we gotta stop. Okay, let's try this one. Let's say hello. It's going to be this. If n is wait. If n is equal to 1, we're going to print hello. Else we're going to call, we're going to print hello, and then we're going to go hello n minus 1. Okay, okay. Now let's even say, okay, now we're gonna do it like this. Okay, hello boss, what are we making here? Hello Path, hello Path, welcome to the stream. We're not making anything, we're just solving some DSA questions. We are solving some DSA questions. That's what we are doing. How are you doing, Path? How was your day? How has your day been so far? What did you do today? Okay, so this should work. We should, if we say 3, we should get 3 hellos if I'm not wrong. Okay, something is okay, it's because I don't return. Basically, and this is actually a great, it's good that this happened, because when you don't return from a recursive function, it happens something called as infinite recursion happens. That means that the function is going to keep calling itself infinitely. That is why we have this. This is our base case. When we reach this, we're going to return, and that's what stops our function. There we go. We get 3 hellos. We get 3 hellos. All right, there we go. So right here, it doesn't matter. I'm pretty sure it doesn't. I am pretty sure that it does not matter whether you put hello here before the cout. I mean after the cout or before the cout, because right here we're not really working. Yeah, so I can put 5, and it's gonna be 5 hellos. One, 1, 2, 3, 4, 5. Okay, 5 hellos. So uh, it doesn't matter if you put, so in the previous functions, now here, when we wanted to print from, I think it was, okay, no, here, when we wanted to print from 1 to n, we had to put the print line, the cout line, after we called the function in itself. And here, when we wanted to print from 5 to 1 or counting down, we first put the cout and then we put the recursive call. But here, we're actually not really using the value in our answer. I mean, in our answer, we're not really using n. We're not printing n, we're just printing hello. That's why we can put this either here or here. It doesn't matter. It's still both work. Both work. Both work. Okay, let's try next one. Countdown to blast off. Okay, so this is basically what? This is basically this one. This is this one. Okay, I'm just gonna copy paste this. I'm just gonna copy paste this. This is basically this one, but let's call this print 3. But instead of just couting 1, we need to also cout blast off, and this should work. Print 3. Let's see. Moment of truth. Okay, there we go. 5, 4, 3, 2, 1. Blast off. All right. Okay. Or we can just do like in the example. You can just do it happens 3, 2, 1. Blast off. All right. Oh, DSA, I see. Yeah, bro. Pretty much. Uh, Path, are you a student? Are you a software engineer? Like, at what point are you in your career? At what point are you in your career right now? I would be very curious to know. Okay? I mean, guys, we already went through, we already went through, what is this? No print 2. We already went through this, how this works. So this is basically the same. This is the same. We just add an extra C out. Okay, let's see the next one. Power function. Okay, power function. A n minus 1. Okay, so, all right. So let's do this one. Now, I am not a master of recursion yet. I'd say I have a pretty good grasp of the basics of recursion, which when you are solving recursion problems, you have to make sure that your basics are very strong. What are the basics? The basics are the base case, the recursive call, and you need to know like about this where functions return from and how and about the call stack. That I'd say pretty much that's the basics. The call stack, the base case, and the recursive call. That's pretty much it. Okay, so this first power function. So it's going to be a to the power of n. A to the power of n. Power. A to the power of n into a to the power of n. And so if n, I'm guessing if n is equals to 1, we're going to return, actually if n is equal to 0, we should return 1 because every number to power 0 is 1. Every number on when you put every number to the power of 0, that number becomes 1. Okay, so and then we're going to return 8 times power of a n minus 1. Okay, and this should work. This should work. Okay, so let's say power, what is it, 2 and 4. This should give me, let's see if it works. Okay, okay, I'm not printing it. This is not a void. This returns a value. Okay, okay, there we go, 16. Okay, guys, again, this is basically the same as this and where's the other one? And this, I already explained this. I already explained this. I already explained this. And now this is basically the same. It calls another function. The recursive call is here to the right. Okay. This is I explained this already. All right. Okay. Okay. Uh, thank you guys so much for 50 views. Thank you guys so much for 50 views. I love you guys. I love you guys so much. I love you guys. Okay. All right. Let's see the next one. Sum of digits. Oh, sum of digits. Okay. Okay. So sum of digits. Digits. And then we're gonna get an n. Okay. Okay. This one. 4 plus k. Okay. So let's see if I can solve this one. Let's see. Okay. So sum of digits. So if n is equal to is equal to Okay, this one is a little more challenging. This one is a little more challenging. So if n so 3, so each time we're going to want to divide n 3. Okay, so we're going to return end of this plus sum of digits of n divided by 10 of n divided by 10, I think. And then if n uh hmm, if n divided by 10, keep up, brother. Thank you, Night. Thank you, Night Fury. Welcome to the stream, man. Thank you. And yeah, thanks, man. Thank you. Okay. Okay, let's see if n divides 10 is equal to 0, return n. Return n. Okay, I don't know if this is gonna work, but we are going to try this. Sum of digits 1, 2, 3, 4. We should get 10. Okay, we get 10. Nice. Okay, so that is, and then 1, 2, 3, 4, 5. We should get 15. Okay, we get 15. Okay, guys, this is, and this is also kind of the same again. So we get, it's plus the next function call, plus the function call. And you just, I mean, if you have figured out the base case, that's basically like half the problem. If you have figured out the base case, uh, you're making good progress, pretty much. Okay, all right. So this is not this. I don't think this is with what I explained already. You guys should be able to get this one as well. So basically, this what this does, it means if this is a singular digit. So for example, if this is, let's say we have exhausted all the other digits and we are left with one only. 1 divided by 10 is gonna give us 0, and then we're going to return 1, and then the sum of all of the other digits is gonna follow after that, basically. Okay, product of digits. This is kind of the same again. This is kind of the same. Should the only difference should be this, like that. Okay, I think that's gonna work, but actually let's just in case put this like this. Say product. Okay, no, not some product of digits. Product of digits. Let's say 1, 2, 3, 5. This should give me 30. Bro, I want to learn from basics. I'm under Hello Nobita. Hello Nobita. I mean, if you're asking for resources to learn, just go on YouTube and type in "Take You Forward." You can learn from take you forward. DSA play list on YouTube. That's a great playlist. It is completely free. It's on YouTube. You can learn pretty much all the basics from there. You can learn pretty much all the basics from there. Okay, this should give me 30. Okay, or Kunal Kushwaha on YT DSA. Also, Kunal Kushwaha, you can learn from that guy as well. Wow, thank you guys so much for 70 views. Thank you guys so much. Okay, all right. Okay, let's see the next one. Count zeros in number. Okay, guys, I think we're going to try to do this one, and then we're going to finish the stream for today. Okay, so let's say count zeros. Okay, what is the count zeros? Huh. In number, int n, int n. Hmm. Okay, the only thing I can think of is if we put a count. If we put a count, if n time divided by 10 equals 0, if n 10 is if n is equal to 0, we're going to say count plus plus, and we're gonna return. Okay, this one I'm not sure about. Okay, I saw that's brother. I'll recommend you Striver's A to Z DSA sheet on YouTube. Yeah, man, that is also what I would recommend. Striver has amazing lectures. They are completely free. They're on YouTube. He also has a website where you have practice problems which you can do after you learn a topic. All right, guys. I mean, uh, that is basically going to be it for today. We have been streaming for over an hour. That's gonna be it for today. Make sure that you like and subscribe, and tomorrow I will be back. Tomorrow I'm going to stream again at 5 p.m. 5 p.m. EEST time. So thank you guys so much for joining, and I'll see you tomorrow. Bye bye.